What physics allow electricity to travel long distances? Imagine trying to send a message across a huge city without losing any of it along the way. That's kind of what electricity does when it travels across the power grid. But how does it make that journey without disappearing? Well, it all comes down to some simple but powerful physics principles. When electricity moves through a wire, it's actually moving electrons, tiny particles that carry energy. The key is how we control and manage this flow, so it can go for without losing too much power. First, there's Ohm's law, which explains how voltage, current, and resistance work together. Voltage is like the pressure pushing electrons through the wire, while current is the flow of those electrons. Resistance is how much the wire resists that flow. When electrons move through a wire, resistance causes some energy to turn into heat. This is called resistive loss. The longer the wire or the thinner it is, the higher the resistance and the more energy gets lost as heat. That's why we use special materials and designs to keep resistance low. Next, to send electricity over long distances efficiently, we need to increase the voltage. Why? Because power is the product of voltage and current. If we keep the power the same but raise the voltage, the current drops. Since resistive losses depend on the square of the current, lowering the current makes a big difference. That's why high-voltage transmission lines are used. They carry electricity at thousands of volts, sometimes over 100,000 volts or more, which reduces the energy lost during the trip. The materials used for these lines also matter. Conductors like aluminum and copper are chosen because they have low resistance. Aluminum is lighter and cheaper, making it ideal for long spans. Copper is more conductive but heavier and more expensive. These materials help keep energy losses minimal and make the whole system more efficient. Transformers play a big role too. They are devices that change voltage levels. Power plants generate electricity at a certain voltage, then transformers step it up to very high voltages for transmission. When the electricity gets close to where it will be used, other transformers step the voltage back down to safer, usable levels. This process makes sure electricity can travel long distances at high voltage and then be safely used in homes and businesses. For extremely long distances, another technology called high-voltage direct current transmission is used. Unlike alternating current, which switches direction many times a second, direct current flows in one direction. High-voltage direct current systems reduce losses even further and allow for more precise control of power flow. They are especially useful for connecting remote renewable energy sources like wind farms or solar plants to cities far away. All these physics principles work together to make sure electricity can travel across hundreds of miles with minimal loss. They help keep the lights on in your home, your office, and everywhere in between. Without high voltage, low resistance conductors, and smart technology like transformers and direct current systems, long-distance electricity transmission wouldn't be possible. It's a perfect example of how understanding physics helps us build better, more reliable power systems.